Hey everyone, today I'm going to do a parametric precedent on the twist by Big Builds. So I have the Google image up. So it's actually a relatively simple form, but it's also a very elegant way on transitioning through different types of thresholds. And I think that's a really unique part about this building. I'll just probably do the massing of it. I don't think I'll do any of the interior. I know how they did the interior, at least in terms of the windows. Maybe I'll do that. It doesn't look too difficult, at least. If I do this. I have some water with me now. Excuse me. So, yeah, I think I know how they did the windows from how I'm thinking about it. Yeah, let's see if we can do those too. But for right now, we're just going to do the massing. So I'm just going to create both sides. Since it's a bridge, I'm going to create both sides of the bridge. So I'll just do two boxes, two identical boxes. In Rhino, copy. And that's what I'm going to start with. I can always expand this out further, but I'm going to start with probably this for right now. Make sure this is on the 0. 0. We all good there. Alright, and now let's just get started. So what I'm going to do is probably going to find a point on here. Probably start with the midpoint here. I'll just literally make a point in Rhino. And I'll have this. It just depends on what I'm thinking here, because these don't really need to be referenced. It's mostly these two lines that need to be referenced that I'm going to create. So I'll reference those curves first. So do a cell curve. Not all of them, actually. Set one. Enter and select the other. I will select multiples. And then I will start to probably do a point on curve for both of them. And then do a distance. Does it tell me the distance between both? So it should just do a distance directionally. I want to check first before I just rely on that one number. So I will do this, draw a line, and then do length. I should have the same exact number, 1004, 792. Yep. Okay, so they're the same. So we don't need this one. So cool. So now we have the distance between this bridge, and every time I'll actually group these together. And I'll group these together. So every time I move it, the values will just change. So it shouldn't be that anymore. Yep. Cool. So let's get started. So what I'm going to do is start with a point. I'll start with 1 point. Let me think how I'm going to start with 1 point. Yep. Reference that point. I could also just use the midpoint curve. So instead of actually having that point right there, I could just use the midpoint of that curve. So it'll be this one. And actually these should technically be backwards, I think. Right? Yep. Okay. So what I'm going to do now is take that point and create a what's it called? Sorry, a rectangle on that point. So I could create a plane that's perpendicular to that at all times. So I could do actually a perpendicular plane or perpendicular frame. Would it be perpendicular? No, it'd be horizontal, sorry. Or would it be perpendicular? Man, I'm tripping right now. Perpendicular frame. Let's do 0.5 as well. And then we just have to reparameterize. I think horizontal frame, no. I probably just need to take this plane. How I'm thinking about it is take this plane and just rotate the rectangle. Like if I put the rectangle here, it's just gonna make the plane on the rectangle. So maybe if I rotate it, always saying no matter what direction, rotate 90 degrees, it'll rotate the correct way. So I can always just test that out by doing a rotate. Rotate the geometry. I could do plane, could be that point. Geometry could be that. And since this will always stay the same, I can actually just plug that, not that. I can always just do a numbers, do a panel and plug that in, so I don't change that by accident. So this is set to 90, should be. So I'm actually going to turn into degrees and do a panel of 90 instead of a slider. This will signify that I am not changing the value ever. So let's just test it out. So the panel looks like that. So if I just rotate it, like if I turn off, I do that, it should always be, yep, okay, cool. Just want to make sure it works. Test your stuff out before anything. Now I'll draw the rectangle. And it's asked for an XY. So I'm thinking also the X is kind of in the wrong direction. X is upwards while the Y should be upwards. So I may have to just play around with dimensions a little bit. But if we do like maybe a 25 by 25, just to look at what's going on. Okay, so it's reading like that. So we know that the Y dimension here, you can do a construct domain, do 25, and also do a negative. Like this. And then for the Y, we would just, or X, we would just say, give it its own number slider. And just change it based on that. So this will always change in conjunction evenly with it. So no, I want to make this value 1,000 or a range of 1,000. So I can change that, Excuse me. So it looks like in this, they went long ways first. So I'm going to do that first, or taller, not long ways, made it taller. So I'm going to do that actually. So this should also be 1,000. Hit OK. Okay, I typed the wrong number into the wrong place. 1,000. Hit OK. And then let's save that. That looks pretty good. Maybe shrink this down. It looks a little fat. Yeah, something like that. So now we can get started with actually transitioning the rectangle between from this state to this state. So what I'm thinking, so I don't know if I'll get it exactly. I may need to change the kind of endpoint of this. But what I'm thinking is I can do first it'll be basically like the Canyon Tower or like a twist tower. Very parametric thing to do. So you would just do a move. And we're actually going to not use any like vectoral values like X. That's not it. X, Y, or Z. Or Z, not Z. Actually Z. Either way. I'm not going to use any of these because once if I want this rotated. So what I'm going to do is I'm actually going to use the vector based off the planes I have. So I'm going to use the plane given to me here. And I have to look at the plane pretty carefully, but I'm assuming that if X, Y, if I rotate it, oh, I don't know what that is. Y, X, Z, or Z should be, the positive Z should be this way. So I can just do a deconstruct plane. Oh, that is not spelled right. Deconstruct plane. Plug this into here, and I'll get my X, Y, and Z axes. So to test it out, I'll just plug it in real quick, just to see. And it looks, yep, it's working. So it's just very faint, but you can see it's moving like 1 unit. So now I can type in amplitude, plug in the vector into here, plug in the motion. Now I can do my series. We can do our distance here. Actually, we can just always keep our distance here. I'll just do a large panel. Well, not that large, but maybe large like that. 1967. So we could do an exact. I'm thinking maybe we could. If we do, this takes a little bit of math because I'm thinking we have to have number of steps, then a count. So we could have it always start at 0. This would be better with range, I'm feeling. I just like, if I did range instead, I think this would be a lot easier actually. If I did range here, and did construct domain, and then do a series inside of that, I think that would be a lot easier. I don't know, I just feel like range would be so much easier than like the series. The series would just kind of go on. Sorry. I just feel like range would be easier, but I don't know. I'm thinking about it. If I did like a 25 here, see, I plug this into here. Oh wait, so my domain ends here. Okay, so I will get that exact value, but number of steps is determined by this number. So if I type in 25 here, I don't know, I'm picking 25 now. I usually pick 12. Yeah, there we go. That's a lot easier. Yep, so we have this. Okay, so series we could use if we just had like a variable height, but in this case we have actually defined distance. So if I move this, it'll always kind of converge to that element, which is cool. So I'm going to save real quick. So I'll go to my kinetic architecture. What is this called? The twist. The twist. I'll name it twist bridge. Yes, it is. Okay. And I'll name this file the same thing. Go into kinetic architecture. The twist bridge. So I have those files now. And what we can do now is we can think, okay, now that I have that, I just need it now to rotate this point and then continue. So let's try doing that. So I'm going to do a rotate here. I'll get the area of each one, or the center point. There's 2 ways you could do this. You could do the area like this, and that's easy, but this takes a little bit more computation. Or you could do, what I'm thinking is do an explode. And then take all the vertices. So you just do a list item, get all 4, do a subtraction, and this should give you the center. I think that's how it works. Or is it add? I can't remember exactly. I think it's add. Subtract, or is it add? I think it's add. Addition. I can't remember. It was something like this. Why am I not? I feel like I'm bugging out. I just can't remember. I don't remember which way to do that. But so we're gonna stick with this way. It's just easier. It looks easier too. So yeah, I apologize for the coughs. I just am not I'm still a little sick. I'm also trying a new mic out, so I'm trying to get a feel for how close and far I should be to the mic. This will take some getting used to, so right now I'm relatively close to it, but if I get too far, then I don't think you guys can hear me, so I have to like get kind of close to it. So what I'm going to do is take the geometry here, the rotate geometry, ask for an angle and a plane, so I may have to just add a plane to, I don't know why I have to, a plane to these, so let me think, maybe, I mean I have the plane already that I created, I just have to do a perp rotate, I can just do move to point, geometry, point A should be the origin, point B should be the area. Yep, cool. So now I have the planes for those, so let me just test real quick. I just rotate this. Cool. The planes are still normal to the surface. So I do save. Let me just save. Let me take those now. Rotate, move, transform. So I have these planes moved. Okay. So these ones, the geometry. So I know I want these. Plug this in, and you see it just rotates all of them. Now that's not what I want exactly. So I'm going to do a range here. Change this to degrees. And first I'm going to do this as a full twist before I do like a kind of partial twist here in a sense. So let me do that real quick. So what I'm going to do is create this and do a list length of all of those planes. This should give me the exact number I need, and then I'll subtract those to get the amount of steps. So //1 should give you a panel. Steps, angle, construct domain. Do 90. Easiest number to pick right now. And then we can also turn off these existing ones. Yep, that existing one. You see we got a twist, but we want it more cornered. So what I'm thinking is actually having an even number would be really useful here. So we have steps of 62, but the number actually ends up being 63 rectangles. So we can make this number only be odd. And now we should have an even number in the list length, 64. So that would be good to have. If we have that, okay. And we can do is actually do a little bit of math. And what I'm thinking is do a division of this and divide it by 2. So we get 32. And it'll only do one part of the domain. Let me think. Because I want to only do one part of it. So if I only did half, it'll really rotate only half of it, kind of like that. But I want it to start more in the middle, not the beginning. So I have to think, how am I going to get that to start? Because right now it's starting in the beginning. It looks very similar. I just need these to shift and also make the angle a bit less. We'll see. Let's see. If we have steps, it starts always from the beginning. If we, let me think. If we had, This is a little difficult because all I want to do is make it to where it's just where these ones are rotating only, and then it just keeps going. So maybe if I just feel like it's like good practice. I could do this one way I could do it, I'm thinking, is you could do a list item. And then we'll always start from that and then continue forward. Or I could do a split list, but I don't know if that's... I feel like this is a really... I don't like doing split lists. They're very finicky, in my opinion. Yeah, I don't like that idea. Let me think. Because right now I have what I want. This type of articulation. Let me look at this. So I want the angle, I want it to start rotating. Maybe a graph mapper would help me out. I just feel like maybe a graph mapper would be a good way of generating it to read 0, 0, 0, 90, 0, 0, 0. Or, you know, start from this area and then keep going from there. That's what I feel. If I did a Gaussian, I mean, I have the range thing here. So if I plug this in, do my subtraction again that I deleted by accident. Not by accident, I just deleted it. I don't know why I said by accident. Here, plug that into there. Move these all here. Plug it in like this. Create this. So it is changing something here. Maybe I need to increase that value. So maybe the effect is like 9. You can actually just look at the number slider panels and see what numbers is generating. Very low numbers, very, very low numbers. So 90. That's kind of what I want in a sense. More like to be like that. Maybe not that dramatic. So if I lofted this together as just a way of understanding what's going on, I can kind of see it's going a little haywire. One thing I do like about this is though it's actually, you can actually move it. So maybe I just need to change. Hey, we got that. Is that exactly 45? Oh, it's 44 maybe. And then, let's see. That should be the highest number technically, in a sense. Not the highest, it should be the... I got that's close enough, 45.51. So, we can now move this around. Oh man, that's not working either. Dang it. Okay, so because I want this to remain the same. So, let me think. Maybe I'm overthinking this. So, I just want it to rotate this portion. I'm trying to think. I've done this before, I feel. It seems really simple. I'm just overthinking it maybe. Right now it's rotating 45. And that's that one. Maybe if I isolated The steps is the way to do it. I just have a maybe if I do a construct domain on which parts. So if I did this 0 to actually maybe this is it. Oh wait, oopsie. Okay. Let me put in some sliders. Maybe if I do like 12 to 20. And of course it's failing because it can't do like numbers like that. So we're getting close. That's kind of what I'm thinking right now. The list is reading strange. Maybe if I had this at 59 and this 33. No, that doesn't work either. Has to be here. Okay, so what I'm thinking, change this to 90. So I can just see a perfect view of it. So what I'm thinking is it'll start from there. It'll start from here. I just want to control the starting point, which is what I'm doing here. So this is 0. It's weird that the starting point is there, and it's also here. It's just a little strange. Like, I just feel like it should have both sides. Would it not? I feel like I'd have my own range within a range. Or a series, maybe. Like, you'd have a range within this. This is close to what I want, but I want it to be able to control where this starts. But it just seems like it's just for 0.0. Well, if I had a negative number, let's try that. I feel like having this move over and telling it to start at point this would be easier. With steps. Sorry about that. Try to cough away from the mic. It's pretty hard to do. I don't know why it's so sensitive to coughs. Maybe I'm thinking about this wrong. I do series and I do steps. Series looks like it's getting somewhere. It actually has a start, so that's exactly what I'm looking for. So I'll start with 0, obviously. My count will be the amount of stuff there is. 64, right? I don't know what step is exactly. I think step would just keep the same. No, I think this is degrees technically. The count is 90, right? No, the count's 64. That's right. It's just counting. That's all it's doing. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. It's just rotating until. So what I think in this case, would I have to change this to be 90? So I just do 91, and then tell it to start at. I just feel like. Or maybe I do for this count. That's 90. It starts at 7. That's 7 degrees, not 7 literally. I feel like maybe if I took the geometry of what I want exactly, like kind of the proportions, could I do a list item with multiples? If I did like a construct domain. And I did like, this is 0 and 1, right? Once if I label it 0, well, no. Let me look at lists real quick. Domains, no, sets. It has to be starting from one half to another. So I think maybe split list maybe where it should be. If I started with, let's say, 12. List A and list B. Let's start with this one. And then the rest. Yeah. So maybe having that would be useful. Oopsie, delete that one. This is an important number. So maybe having those would help out. I think I would have to have another split list where that origin's at too. And it would need to be in the exact same place. And it needs to be where the perpendicular plane is at as well. So these all need to share that same number. List B. List B. And then, oh, it's empty data. Oh, that's only one plane. Not that one. Needs to be. What am I moving here anyways? What was I moving here? Okay. I am moving out this one plane. I'm moving this one plane over to these area points. So I have to do it to this area here. Right? With point A being these. Okay, yeah, that's right. I only need to do it to 1 from my logic. Yep. Okay, cool. Okay, so doing that. Boom. And then I can do the rotate based on this one. And I can merge them together. I can weave them together at the end. So that's what I'm thinking. I don't need to loft this. I can just kind of visualize it now. And I can do Then I can do range, I feel. Then construct domain. Plug this into here. And then put this at 90. And see the results. Okay. Let's see what this gives us. I can't see what's going on. Probably one of these has to be the rectangle. Yep, okay. All right, so we have this. We're getting close, and what I'm thinking now is this will be the steps. If we can do steps, we would do probably 12 starts. Maybe, that's what I'm thinking. Start with that. We can do curve to show these. So we're getting somewhere. This is pretty good. I want them a little bit more smushed, but I think in order to do that, I just need to add more points. It starts at 19. I kind of want it to start right there. I want it to be like that. Yeah, something like that. A little more. Okay, there we go. And then move this over here. And yeah, okay, all right, we got it. Cool. All right, so once we have that, what I'm going to do is do a merge. Either a merge or I think a weave would be better. Would it not? If I had this one plug into here, this one plug into here, and then I do a loft. Well, that's not right. Okay then, so that's not right. Merge. Let's look at the list. It should be partitioned out in some way, right? Polyline. Oh, they should loft. They're closed. Everything's closed. Okay, cool. Merge works too. I think weave like moves back and forth between two lists. So, not think. I know it does. I just think weave is somewhat superior sometimes. So yeah, have that. Let's see what this looks like in preview. This is not exactly. I want to do also the kind of cubic shape it has right here as well. More of the kind of, what's it called? The layering effect it has rather than like extruded out. So if you do the geometry preview like that, this looks good. So what we can do now is ungroup, scale 1D this somewhere here, and I'll group it back up. Okay, so we can move this back now, something like that. Cool. All right, let's save everything. Remember, once you get the solution, save. It's important. Okay. Sorry, I just have a really bad sore throat. I need to get some like cough drops or something. Or drink some water would be useful too. Water always tastes good. So you can also increase the number of points. What is this? 91. I mean, this doesn't need to be 91 anymore. It could be whatever. Yeah, it's still gonna rotate 90. 91 just happens to be where it's at right now. Change the dimensions of it. And where is the number of them? It has to be here, series. This is it, right? Yeah, this is it. So this one. Okay, so script's not super long actually. Very simple script. So now that we have our loft was just a preview test. We actually don't need that. What we need to do now, I'm going to flatten this just in case. I'm going to do extrude. I'm actually, no, I'm not. So what I'm going to do is I'm going to take a origin of each one of these. The area of every one of these. I'll do a list item on just 2 points. Doesn't matter. So I'll do 1, 2. Do distance, and plug these two in. And why is this not working? Oh, I plugged in the area. It's numbers. Okay. So I'll have these two numbers, or these 2 points, and they will give me a distance of whatever those rectangles are. So whatever that number is, and we can do an extrude. Extrude. And then we can move it in, what direction? I'm bugging out right now. I'm going to do amplitude. And we can use the vectors from what we did here previously. So we can tell it the z-axis. They're all extruding at some variable amount, or 1 actually. Plug that into here, and then do a cap. And now we got that twist effect that's going on, and theirs is a lot thinner, so I'm actually just gonna increase the number size to like 1,000. I'm actually going to do something like that. And I actually won't have this extrude. I actually won't have this extrude. I'm going to disconnect it first. And I'm going to move the steps over here, or widen it out a bit. That's number of them, and this moves it. Yep. And this should be kind of the same value, 1,000. Move it over here. And then now we can plug this back in. And we can also do like a preview, custom preview. Turn those off. They also have, what it looks like is they have, it looks really defined really well. I think that's just how they rendered it too. Because like you can see that the geometry here has, it's very noticeable. That means it has like some slight rounding, like super light rounding. So we can actually do a fillet maybe. Fillet edge. Or actually this would be even easier. If we just did no, that would round the corners, not what I need. So we could try doing this. Now before I do this, I'm going to save. Shape metric edge radii. Probably like 0.25, something super small. The shape to fillet, blend mode fillet, metric rolling ball, edges to and nice. So if I do a deconstruct brep, catching on fire, I can do edges. First I'm going to do a list item though and grab all 4 of those. So you're left with those. And then once you do that, you can start to figure out which ones are which. So I'm going to do that real quick. Oh no, it's not point, it's curve. Curve 1. So I just want it to be the sides. I could just do all of them actually. Doesn't hurt to do all of them. I think it'll look nicer too, actually just slightly rounded. What does it say here? You may not specify more radii than edge. Well, there's no edges. Alright, cool. Well, I just made some edges, so there, boom. Take that. Maybe there's a lot of geometry. Maybe I shouldn't do this. um, yeah. So, anyways, that's how you would do it. I think I pretty much got the gist of it. Whew. Maybe adding like a tiny gapping in between them, but I don't know. I feel like having it exact is kind of nice. I want to, if this ever loads, good thing I saved it. So actually what I'm going to do is I'm just going to force quit it. Since I saved it, go to your good old task manager. Don't close OBS because that's the only way you guys are listening. End the task. Go to Rhino. I'm going to open up here. And then open up here. Open. It's not in side projects. It's in kinetic architecture. It is called Twist. It's called Bridge. Is it not? Let me find it. Twist facade? That can't be it. The Twist Bridge. There we go. Alright. Open that up. I don't know where that other block is. Probably like over there somewhere. Open Twist Bridge. Ignore recovery. There we go. Yeah, it was on the other side. Okay, so let me space these out evenly again. Delete this. That's just me trying to be superbly anal about certain things that don't really matter at the end. So I can actually hide everything but the preview. Now we get this kind of articulated mesh, which is super nice. Not mesh, the NURB curve or whatever you want to call it. And it looks pretty similar to this. This is a lot more smoother though for some reason. Maybe they had more. Let me look. Maybe they had a lot more transitional. So I start from 77. Okay, so this looks a lot smoother actually. So what I'm gonna do is probably like mine starts like this and goes up a lot. I don't know, theirs just look really smooth versus mine. Maybe it's just a rendering. It has to go up a tiny bit, does it not? If you think about it, yeah, it pitches up here. Well, let me think. So if you're rotating this, it has to pitch up. I can't see the whole building. So if there's a Google image of, oh wait, there it is. Okay. Excuse me. Open image in new tab. So they have it like this, and then like this. Yeah, it just looks super transitionally nice. I don't know how they manage that. I feel like having it like how I have it is one of the ways of doing it. Yeah, there's transitions like super nice. All the twisting happens within the geometry here. So maybe if I just feel like having maybe more numbers. I don't know. I just feel like that's just a division thing. Because if we look at it, how it is right now, theirs is flat and then goes downwards. Mine peaks up a tiny bit here. I don't know. I don't know how they achieved that sort of articulation. Because it's also my geometry may be just a little bit wonky. Maybe I need to start off with more of a more linear square. So if I start off with something maybe like that. But you see it pitches up a lot here, while this one doesn't pitch up a ton. If we zoom in here, it's just like a downward slope. And it looks really nice, like how they have it. I just don't know how they kept that flat. I don't know if this exactly is flat. It geometrically doesn't really make much sense. Like if you have, let me think. Well, hold on, let me think. I'm thinking of it like as if you twist the thing, literally, and you rotate it. I'm thinking like if you just twist it slightly. I mean, I don't know. Maybe there is. It's just not as hidden. It's just hidden more than mine is. Because mine looks pretty good. It's just how... I feel like maybe they used a bit of Graph Mapper for this. It's just... That's what it seems like. Well, maybe not. I mean, I don't know how they achieve that, because, like, it doesn't really make much sense. Like, how, if you twist it, the geometry, how it is right now, it's going to leave that effect of this top part. Why are they not twisting at all? Maybe it's just... This goes down, right? Maybe I'm just really overly anal about it, but it just looks super smooth on the top part. Like the top view helps, but I feel like having like a side angle view of it, which I can't seem to find, and that's Minecraft, so that's not what I'm looking for. And that's a jacked dude. That's also not what I'm looking for. Maybe they have more images. The arc newspaper here. They could have also just like manually cut that off, like how it would be normally. Yeah, it goes like, it smoothens out, which is super interesting. Maybe if because this doesn't smoothen out like how this is. It's a very close replica, but it's not exact because it doesn't have the, I mean, no, it does lift up. You can see it lifts up here, it just doesn't lift up at the very beginning. Or am I twisting the wrong way? No, I'm twisting the right way. Or maybe it's just so big in scale, it looks like it's tapering out, but it's actually going up. I think maybe it's just a scale thing. I don't know. It just, my mind can't really wrap around that. So I'm just going to leave it at that for how it is right now. I think it's a pretty good replica. I think that looks pretty good. Yeah, that looks awesome. Okay, so if we look at the building more, besides that, they have this glass that's quite interesting. How they have it scripted is it starts off here and then expands. Oh man, that one I'm actually gonna do that. That looks interesting too. So I'm actually I'm intrigued by the challenge. So we can actually disconnect these. If they had this, that means it's not only is it just non-extruded, it's also split up and create its own curvature, which is kind of crazy if you think about it. That's awesome. I have no idea how they did it right now, but I'm gonna figure out. So so let's think. If we had, so we know we have it isolated to where it starts. Okay, well, not that one. We have it isolated to where it starts. And this is kind of the key of it. So I think if we did a list item, we need to figure out which edges are which. Not list item, I need to explode. My bad. Explode, list item. It should be either 2 or 0. It should be 1 or 3. It's not one of those then. Okay, it's 1. So I'll keep that at 1. And that's good. So now we have those edges isolated. Also, yeah, I keep in a lot of the mistakes I make and a lot of the troubleshooting I'm thinking of, because this is kind of the process of designing in general, or the process of trying how I do this. So I don't want to like hide any of that in a sense, because I feel like a lot of designers like to hide their mistakes. I make a lot of mistakes, and I consider myself a designer. I'm not perfect. So I have those edges, and this is where the windows kind of take place. So what's interesting, what they did is, how I think about it is they didn't evaluate curve or length. I mean, either one. They did one of these. They reparameterized this and then played around with having the numbers have some sort of relationship between the endpoint and the beginning. But they had it to where it only twisted. So I think if we isolate that geometry to where it's only twisting, will be really useful. So as you can see, if we do a panels here within the range, you see eventually this ends up being 90. Wait, what? Wait, hold on. I mean, yeah, it does. Excuse me. So 90, 100. Actually, this has isolated all of the numbers. So if I did maybe if I do another split list, I really don't like these split lists. I just want to capture a part of it. Not this one. It should be, I feel like I've used this. It's not partition. So pick and choose. I don't want to use pick and choose. I want to use like a, if I did that, and then let's do curve. List B should be all the bullcrap ones. List A should be all the twisted ones. Yep. So they did something really interesting in this one. So not only they did that, they also did like a series What? What is it doing? Oh, yeah, I have it at 10. So if I do, or maybe they did a range. I feel like they did a range, so they can control it easier. And why is there a lot? I have no clue. Anyhow. Yeah, they had something like this. And then they did a list length, subtraction here. Oopsie. 1 step domain, and they had it something like this. Their windows are really nice. Like, they're very, very well articulated. That's the beauty of the project, in my opinion. So do 3/4 of the entire thing. Something like this is what I'm thinking. I don't think they start at 0. They start at like 0.25 almost. Like something like it pinches a lot more than that. Like that. That's such an interesting articulation they made. It just expands out, but such a gradual way. And these are like kind of like quarter here and a quarter here, or 3/4 here, which is kind of what I have here. I may make this like that. They did something like this, and that's such a nice articulation they had there. Okay, and let me look at the reference image again. So they had something like this. And then they have it spaced out here. Okay, let me think. I'm just seeing, the one thing I'm really confused about is how they split it up so well. Like, it looks really well split up. So it's something I have to think about, like how they carved that out. How they told it to stop extruding at those points. That's going to be the tricky part. Maybe not. I feel like maybe not. The reason why I say that is if I did more of a, move these down, I'll move these up, away from everything. Maybe if I did something along the lines of, with that merge, has an offset, because it's just an offset to create the thickness of those articulations. So what I'm thinking now is, what happens if I, yeah, I think maybe creating that as a curve would be better. I'm thinking, like, they had it's really well done. Like, I have to give it to them. And I'm trying to think how they extruded that out. But if I did let's say if I did the other side first as well. So I had split list, this curve, same thing. Don't know why it'd be any different. Yeah, there we go. Could probably just do I'm gonna copy these, so I just don't feel like retyping all that out. And then I'll do evaluate here. Reparameterize these ones. Flatten this. range here. Range there. And then construct domain. Wow, that was loud. Plug this into here. I may not even have to do any of that for this one. I just thought about it. If I just did like 0.16 for this one, I'd get the top one, right? Did they just abruptly end it? No, it's a smooth transition. So they had one evaluate curve that did this, and then they had one constant one. Yeah, they had a constant one that did that as well. So actually, maybe I'll do something like that. 0.3. Or 0.16. I'll keep it at that. And then they had another evaluate curve that did something like this. There we go. How nice is that? I mean, not how nice is that. It's pretty smooth. This one's a little abrupt in some weird regard, but at least it follows it. And then we had this bottom one. Honestly, we could just plug these together. And then we can do 0.84 here. Let's just test. Yep. So I can plug that one in here. Just to simplify some things out. And now we have kind of makings of the window. So if I do an interpolate, I almost want to have it where I almost want to have it to where it doesn't draw a like kind of half cut here. It draws more of a polyline. I'm trying to think. Like, this is a very difficult problem in a sense. Well, they're flat cuts, but I think not having them flat would be okay. But I think that adds to the aesthetic. So it's not exact, it's just more of a half cut. I could do this is going to take a little bit of thinking because it's just let me think. Like, it's just a little bit of a difficult problem. Okay, what if I take the polyline, or mind if I just take it as like, when it's extruded, it looks something like this. What if it had it like so I have it like this right now. And maybe they are, but they are just a bit jaggedy. I kind of like it personally a bit smoother, but let's try it with the interpolate first. So I'm going to try to make it with that first. something like that. So I have all those. Join those together. Join those together. We're missing a little link here. It could be my original split list being 100. No. It could be, so the linkage that's missing here is the one from the start to the end point. So all we need to do is just draw a kind of curve in between that. So what I'm thinking to do with that case is we have these two, or what is it? These 2 points. Where is it? Or we could, actually I have a better idea. We could delete all these and we could actually do a merge of these two, or no, these two, or no, these two, dang it, these two. Yep. So you merge this one and this one, and then, oh, thanks to Johnny. Okay, interpolate. And we have to flatten these actually. Flatten. Huh, why is it still reading like that? I feel like that should have worked. Let me turn off these rectangles. They're very confusing me. Or they're very confusing. Oh, it's looping back that way. It's quite interesting. So that means that data is reading like that as the start point. Is it not? Data 1. Oh, maybe it's reading like that. Okay, so I do a reverse list. And then like this. So this reads like this. If I just reverse these two. Okay. Is that right? That is right. Oh, wow. I was right. Okay. So let's try that with this one. I'll interpolate. And these ones just work fine. Okay, well, that's just fantastic. Of course it does. Save. And we can technically loft these together like this. Not like that. We have to do a loft options. Loft options. Rebuild, adjust. Hit 1 for true. We get this. We can do an offset. I wonder if they have an offset surface solid, which they do. I don't want to rebuild the whole thing. Distance. Distance will be negative. And we'll do a probably 12. Yeah, something like this. And then we'll go back to our components here before we even extrude anything. We look at ours and we offset it. I'm actually going to try this out with a list item first before I do anything. So I'm going to test it out real quick on a list item. Offset it 12 as well. And then we can do a region difference. Sorry, I dropped my mic. Region difference. So curve A and curve B. And then if we do a boundary surface, boundary volume, nope. Boundary surface. Edges. Okay, cool. So it does work. Okay. So you do a little test fragment first and then put in with all of them. That's bothering me. Okay, so this needs to be flattened. It'll crash my computer if it doesn't. Okay. Boundary surface. No data came out. Really interesting. I offset the curve. May have to define what plane first. So let me save. When I do region difference, my computer crashes pretty often. So I want to make sure I do this right. It worked without a plane before. Like if I did a list item. Disconnect. Plug this in here. Maybe if I had two. What happens if I did something like this? And then I plugged both of the in here. Yeah, now it doesn't work, right? Yep. So now it doesn't work. Okay. So let's try. I'm gonna merge these first, just to give it some. So I'm doing this test fragment to make sure my computer doesn't crash. I guess this. Okay, it says empty parameter. So what I'm gonna do is actually first disconnect one of these. And then I'm first going to unflatten this so they turn out like this. I'm actually going to graft these, graft these ones so they read the same at least, so it won't crash completely. Yep. And then I'll plug this in here. Okay, so they both double graft helps. Right? So if I do a boundary. Okay, so that seems to work. So let's try that now on a larger scale. I'll do a graft. Well, first let me save. I'm very nervous about this command. Okay. It made all of them but a couple. Some of the offsets kind of didn't work. So I think maybe I need to add the plane to all of them. Why can I not spell right now? Move to point. And then I need to probably, oh no, I already, wait, if I already, no, that's only the half. So I need the whole thing. So I'm going to plug this into here. Point A would be here. Point A would be here. And point B would be the area of everything. Okay. So adding a plane may help. Oh, no, not that. Adding a plane may help. And the offset. Oh shoot, I just remembered. I have to graft it. Okay, well, yep, I just realized that. Okay, well, my computer probably crashed. Good thing I saved. This is long. This is long, but it's enjoyable nonetheless. $136. Yeah, that's not right. But okay. So we graph that. So the data reads not 136,000 times. That wasn't like triple digits. I was like, what? I was like, so it's offsetting 12. We have to tell it negative. So this will fail it. 12 interiorly. And then we'll do a region difference. Yep. And then, yep, there we go. There we go. Cool, 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 cool. Then we'll do an extrude. We can just use the same one here. And as you can see, there's some interior here. Did their twist have a bottom, I feel? Their twist did. Like, I feel like their twist had some sort of... It went upwards. I don't know why mine's going. I don't know why mine's going like that. This is a pretty close precedent. But let me think. So once you have that, I'm actually going to make this slightly smaller on this offset. Probably do like 9. And then what I'm going to do is bake everything. So bake this. Go to here. Bake everything here. Yep, normal. Close out of grasshopper. Go to Rhino. So it seems to have done everything but this one, but that's okay. So what we're going to do is do a Boolean difference. I usually do my Boolean difference not in Rhino or Grasshopper because it doesn't seem to work usually, and it doesn't seem to work here either. So let's see. What does it say? Surface intersection error. Maybe I extrude it. Maybe offsetting at both sides may be the only way. So let's go to that. Offset both sides, yes. create solid. Oh, it's a solid. Okay. So offset at both sides. Let's rebake this again. Let's try that one more time. Usually it works better in Rhino than in Grasshopper, honestly. So let's have that. We'll hide that. And we'll hide that too, I guess. And now we have this kind of leftover stuff. Oh. Let me delete the preview real quick here. So as you can see, we have our, if I ungroup it first, we have our opening for it. And we can actually add this back in as glass if we want. Not if we want. I'll just add it real quick. It won't take too long. Only thing it's missing is maybe this little lip, but I'm going to keep that. Group. Yep. Go to shaded. I'm actually going to turn off show curves or turn off show surface ISOs because it's just confusing. Do save. Go back to Grasshopper. And now we have our window here. So I'm actually going to change that to not be both sides right now. And keep it as a by the way, 12 inches of glass would be insane. So let's do like even 1 inch is kind of thick if you think about it. So we'll bake this. We have this surface now. We can also, we have this surface here. What's up with this surface? I just want to, all I'm going to do is change this object. I'm also going to change the property layers just to show you guys what I'm talking about. If I do rendered, I'll have this, and then material, default material. I want glass. Hit OK. You can see it's pretty much glass. Has this weird kind of inflection into it, but I think that may be the surface light, how it's entering into the space. Actually, this looks really cool. But what I would probably do is take, no, I think it looks fine how it is. Yeah, this looks clean. I really like this. If I maybe change this, it stayed pink. Okay. But I was seeing if I can change the material to be like metal or something, so it just looks different. And I would change those, but not the pink one. So yeah, I think that's, I don't know what the interior looks like in the building, but this is what the glass looks like. Let's make a little close comparison. So theirs are a lot thinner here. So I think they actually, in my opinion, they used a graph mapper for this to have the same extreme. That's my opinion. I think they have a graph mapper that did that. I just did it by range, but I think maybe how they did it was in here, in this range, most likely they had some sort of graph mapper that exaggerated it a bit. So we can test that out real quick. Evaluate curve. Evaluate curve. Come on, I can't spell. Evaluate curve. Maybe parameterize. Parameter range is from 0 to 1 in a sense. Then graph types, I think they may have used like one of these. So in this one, I have it at 0.84. So maybe it'll be more like this. Maybe I used the wrong graph, but I feel like they used a graph mapper for this. It just makes a lot more sense to me. I don't know what the range of this is. Steps. So I don't know what numbers this is giving it, but this looks very similar. Maybe like that. And then this goes down a bit more. Oh, they also may have used a custom equation as well to derive this. Or maybe they just use linear. And then just played around with it. And then did like maybe something like that. Then they pitched it in a little bit more. Like that. Highly doubt I got it to the exact same domain though. 0.82. Yeah. That needs to go down a bit more. The only way to get it like truly exact, I think, is like through. I mean, through range, I kind of have it. I mean, this works fine because it doesn't even be the exact because then you're going to use the other curve over here in order to create it. So yeah, I think that's how they did it. So right now mine is just a very sloped. This is more manipulated through a graph mapper. So this is one potential solution. And I think this is one way they have done it, I think. That's my theory, that they pitched it in like that. Theirs looks a lot more severe though. It looks like a literal curvature, but I don't know, maybe that's just the image. They could have also played around with the range of it. So they could have started, really, maybe not exactly at 99, but maybe they played around with subtraction here. Maybe they played around with subtracting this and this and doing like a 12. Or something like something like that is what I'm thinking of. Is like maybe they played around with more of the steps of it, like where they start and where they end. So maybe it's more like 64. Or maybe they used, I'm going to keep this graph mapper because that's actually pretty good. Maybe they use more of maybe like a sine curve. They played around with that pitch. Actually, that looks a lot like they did. That looks very similar to what they did. That looks almost exactly like how they did it. Does that not? Tell me. You tell me, guys. Does that look? That looks just like how they did it. But yeah, there's technically no wrong answer. The precedent, honestly, is just a way of starting the project, and then we can manipulate it however we want. But this is one potential solution again to how they did it. instead of using this one, to use this one on how they manipulated it. And that's just one way of how they did it. I think I just like this better too. That pinch looks so good. I love that pinch. You can also tighten it up a little bit too. Ooh, I love that. Something like that. So you can do that or just leave it the way it is, like that. So yeah, I think, let me see if I can just, I'm actually going to exit out of this. Man, this took a while, but it looks really nice, and I'm very happy of doing this because it really taught me a lot too. I learned a lot doing these videos too. Just like, I know Grasshopper, but it's like a whole new set of challenges, and it's so interesting to look at. So yeah, guys, it should be, honestly, if I think about it, like these are already baked. So like, let me ungroup this. So if I take these, I should be able to just move my whole thing. And I should be able to, according to how I set up, be able to rotate however I want it to be. Right? Custom preview. Excuse me. Have that. So you have that. And then the offset surfaces that create the window. Yeah, I think, yeah, you can literally rotate this however you want to, which is really cool. So yeah, guys, I think that's pretty much it for this video. To wrap it up, that's what the script looks like. It's kind of crazy, but it's actually not too bad. This whole section is just for the window, and this whole section is just to get the geometry correct. So yeah, that's pretty much it for this video, guys. Thank you guys for watching. Hope you guys have a great day, and I'll see you guys in my next video. Hopefully it's the Unreal Engine video. But yeah, we'll see you guys later. Peace.